We now look at a slightly different sequential resource allocation problem that involves uncertainty. So in the previous problem, we talked about how to invest a total amount of A in n different periods in order to maximize the return. And there was no uncertainty involved. And here we're going to introduce uncertainty in a very unique way. We're saying that for each period, you may not have the chance to invest. So whether you can invest or not, it's actually random, it's uncertain. And we describe this one by just a two-value random variable, either 0 or 1. If it's 0, there is no investment opportunity. If it's 1, then you have investment opportunity. So let's first write down over here. We have an uncertainty over here, the random variable, discrete, and this is called opportunity to invest. Opportunity to invest, and it's uncertain. And it's going to be either 0 or 1. And the probability for 1 is going to be p. So that's the difference. We can introduce the uncertainty over here. Now, imagine we still have n periods. So we still have the same structure. And this is period 1. And then we have total number of periods n. So this is n minus 1 periods, right? And we have initial amount over here, A. We have initial amount over here is A. But subsequent amounts can be any number. So we can use another x to denote the amount that's available for invest. So x over here, again, we can say amount available to invest. And that's state variable. And we know already action variable, y over here, action variable. And we have y less than or equal to x in general. Okay. For the first period, y is going to be less than or equal to a. But for each period, we have another state variable over here, whether we have the chance to invest or not. So how can we do that? We can say we have another state variable over here. Let's say I over here. It takes only two values, either 0 or 1. Now, what do? We can write down the following thing. We first need the v. V over here is the maximum expected return from n periods, and with your initial amount A, and also your chance to invest is I. Now, because I has only two values, we can write down this is really Vn of A0 and Vn A1. And Vn A0, that means this is going to be maximum expected total return from n periods, and with initial amount A, and no investment opportunity. How about Vn A1? There's only one change. This is still maximum expected total return from n periods with initial amount A and yes investment with an investment opportunity. Okay. So now let's look at what's going to happen if we want to set up the Bellman's equation. First, we need to look at the action over here. Now, let's first look at Vn A0. Now, what kind of actions we can choose? Because there is no investment opportunity, the y must be equal to 0. So y must be equal to 0. You cannot invest anything. And there is no return. But you still have a future. So the future is going to be Vn minus 1 and A, but I. And you don't know what I is going to be because that's tomorrow's investment opportunity. But I has two values. I can be 0 and 1. With 1 minus p is 0, and with p is going to be 1. So if we want to look at the expected return of the future, we have the following. We have expected values Vn minus 1, A maybe 0, but that's 1 minus p. And then we have Vn minus 1, A1, and that's going to be p. You can see the structure over here. This is expected value of a random function of a discrete random variable, right? Probability multiplied by their values. So that's what we have. So we have Vn A0. There's nothing to maximize, and it's going to be simply Vn minus 1 A0 and 1 minus p, and plus Vn minus 1 A1 and p. And that's what we have. Now, we need to find Vn1 A1 separately, and now we can invest y. Y is less than or equal to A, bigger than or equal to 0. If we invest this much, and then we are supposed to have a return. So we have a return of y. And then we have in the future A minus y left. But now we don't know what's going to be the investment chance next time. So we're going to look at the expected value. So it's Vn minus 1. But now we have only A minus y left. And tomorrow, if you don't have investment chance, then that's going to be Vn minus 1, A minus y 0. And that's going to be 1 minus p. And then if you do, then it's going to be Vn minus 1, A1 and p. And that's what we have. So if we maximize over A, and then we have the Bellman's equation. But for this one, we have a pair. The reason is because our second state variable is a discrete one, and we are listing the equations over here separately for their values 0 and 1 over here. All right, I think that's all for sequential allocation model, how to set up Bellman's equation. If we want to find V1, V2 explicitly, if say R of y is explicitly given, we can do that just as we did it before. So we're going to stop over here. There is a typo over here at the end of the Bellman's equation. Let's try to correct it. We're going to erase this part. It should be A minus y. So alright, so if we do have the investment opportunity, then we have, for the next period, we have A minus y left, and the investment opportunity variable is 1.